Hello, and I'm Samira Ahmed, and I'm delighted to welcome you to the Rosalind Franklin Lecture. I'm thrilled to be the chair of the whole series. And as you may know, or you may not know, the Rosalind Franklin Lecture was established in 2016. It explores and celebrates the contribution of women towards the promotion and advancement of aspects of humanism in the UK and around the world. And it's organised by Humanists UK each year to mark International Women's Day. This lecture is, of course, named after the humanist and scientist Rosalind Franklin, the woman crucial to the discovery of the structure of DNA, whose immense contribution went unrecognised and underplayed for decades after her death. Appropriately then, the Rosalind Franklin Lecture often, though not always, is rooted in a scientific theme. Previous lectures have covered vaccinology, psychology, the interaction of science and public policy, with the inaugural Rosalind Franklin lecturer, Professor Dame Anne Glover, touching on the life of Rosalind Franklin herself. However, tonight will be the first time we're welcoming a space scientist, and that space scientist is Dr. Maggie Aderin-Pocock. And I think right now, when we're dealing with so much darkness in the world, I think the idea of looking up at the stars and thinking about our place in the universe can be a welcome thing. It's not to say we're not also thinking about the situation in Ukraine and elsewhere, but we know the importance of thinking about the stars and our place in the universe. Dr. Maggie Aderin-Pocock is a space scientist. She's a science educator. She's perhaps best known for presenting BBC One's The Sky at Night since 2014. But I've seen her so many times as an educator, and her enthusiasm and her ability to convey the complexities of her work in an accessible fashion is absolutely remarkable. Managing multidisciplinary teams, the novel bespoke instrumentation she's made in both industrial and academic environments have ranged from handheld landmine detectors to an optical subsystem for the James Webb Space Telescope, launched on Christmas Day last year. She also worked at EADS Defence and Space in Portsmouth, where she leads the optical instrumentation group. She's the manager of Science Innovation Limited, a company she founded to enable her to engage the world with the joys of space and STEM. And to date, Maggie's directly engaged with 350,000 people across the world. She sits on the boards of the Science Museum, the Unboxed Festival, and the Science, Technology and Facilities Council. She also has a Science and Society Fellowship from that council, which enables her to engage the public with the science work that she loves. She received an MBE in 2009 for services to science and science education, Vodafone's 2019 Woman of the Year Innovation Award, and in 2020 she won the William Thomson Lord Kelvin Medal and Prize from the Institute of Physics. And since September, she's been president of the British Science Association. And so we're thrilled to welcome you, Maggie. And before you begin your lecture, just to remind you, you can submit questions that I'll put to Maggie. We've got a nice half hour after she speaks. Could you use the Q&A tab, please? And I'll keep an eye on those, and I'll bring them up, as many of them up as I can at the end. Anyway, Maggie, welcome, and over to you.
Fantastic, thank you. First of all, the title of my talk is Reaching for the Stars, and because it's something that I have done, I think, virtually all my life, and I'll talk about that. But I also want to talk about the power of a crazy dream, because I think more and more of us need to have crazy dreams. We need to think big and aim high, and I just want to talk about some of my experiences of that. Next, I'd like to thanks, because I'd like to thank the Humanists for inviting me to give this talk, and also for giving me the medal. It came through the post the other day, to much excitement around the house. So thank you so much for giving it to me. And also I'd like to have a shout out for two people, actually. Sandy Togsvig, who is a friend of mine and who's been so wonderfully kind to me. She's a patron of the Humanists, and I think she's a prime example of the sort of human we want us all to be. And also to Alice Roberts, who I've worked with for many years, and she was president of the Humanist Society recently. So a shout out to two fantastic people that I know who were also humanists. I want to give a shout out also to last year's lecture, because in my preparation for this year's lecture, I thought I'd look back and see what was discussed last year. And it was the best sort of summary or sort of input that I've had of how the vaccine was developed for the virus. So I think it was a brilliant lecture, and it's available on YouTube. So if you haven't seen it, please go and check it out. And speaking about the virus, I think it's sort of really changed the way we do things, because I think it's really shown us that we live in scientifically significant times. The virus showed us that, in last year's lecture, the race for the virus showed us, how science is done, how things are sort of set up and prepared, and but also how technology enables us to do things like this. The fact that I'm sitting at my home in my study, wearing my slippers in my very messy study, it means that many of us have been sort of experiencing this. So technology is really sort of changing our lives in so many different ways. But at the same time, I think we're coming out of what I like to call the thaw. We're sort of leaving the virus behind. Things are gradually getting back to normal. I know we've still got a way to go, but it's quite interesting to look to the future now and see where we're going. And I was giving a talk recently, and people were talking about the fourth industrial revolution and talking about sort of the impact of AI in all our lives and in our career decisions in the future. And I think space is going to play a major role in sort of this fourth industrial revolution. So I want to explore that a bit and actually look at some of the ethical issues associated with that. Well, a few years ago, I got an unexpected email, and it was from the World Economic Forum. And I must admit, when I first got the email, I sort of looked at it and thought, someone here is having a laugh, because why would the World Economic Forum get in contact with me? And then it turned out that they had actually made contact because of an article that I had written in a newspaper, and it was called The New Space Era. And for the New Space Era, I came up with this theory that we've only been out in space for sort of just over 60 years. And in that time, space, I think, has gone through three eras. Now, the first era was confrontation. The second era is a collaboration, but now we're entering the third era of space, and it's commercialization. In some aspects, we've been in the commercialization phase for a while, but it's really ramping up at the moment. And so the World Economic Forum saw this article and sort of invited me to join their space committee for a few years. And I must admit, I was absolutely gobsmacked. And I could tell I was outgunned, because they'd send out these emails, and lots of people's PAs would answer, and there'd be me sort of sending back an email. Yeah, I should be able to make that meeting. So it was a wonderful opportunity, and it was really nice to sort of get different people from across the world to talk about space. But I want to dig down into this sort of this new era of space a little. So it's quite interesting, because the first era of space, sort of confrontation, space was all about the Second World War. It was about sort of lobbing intercontinental ballistic missiles as far as possible. And it turned out that clipping the edge of space was a really effective way of getting your missiles to launch further. So space came out of a pretty dark time. And I've got an image here of a sort of a V2 rocket, which is what Germany were using to bomb various countries in Europe. And it's quite interesting, because what happened is that people didn't really think of using space for anything else. And when Sputnik was launched, Sputnik just went into space and went beep, 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 beep. But it was a saber rattling again. It was showing sort of prowess. We had got the first object into space. And so the Russians were sort of very proud of this. And it was, people didn't know what they could use space for. But then people realized that you could actually take images from space and do surveillance remotely. And this was first done, I think, by the Americans, where they actually sent cameras, sort of mechanical cameras, into space that snap photographs onto film, and then they drop the film back towards Earth, and an aircraft would snap that film up, take it back to the ground, and then develop the photographs. So then suddenly space was sort of quite a useful thing, but it's still about sort of a confrontation. And so the Russians got the first object into space. They got the first animal into space, like the dog. They got the first person to space, Yuri Gagarin. And the Americans felt as if they were on the back foot. So again, it was sort of a confrontation. What can we do about it? So they got a man to the moon by the end of the decade, which is the promise that Kennedy had made in his Rice University speech. So all of this was sort of going on, and we had a number of moon landings, but the last one happened in 1972, which is 50 years ago this year. And it's quite interesting, because more moon landings were planned, but the Americans felt that they'd spent a huge amount of money on this, over 4% of their GDP on the Apollo moon missions, and people were losing interest. They'd seen people play golf on the moon, drive buggies. Where was it going? And so they cancelled some of their moon missions because people had lost interest. And it turns out that people were sort of although this confrontation was going on, people were starting to look at collaboration. And in this in this era, in 1975, that's where we get formation of the European Space Agency. And I'd like to point out this epic moment in space. This is a rendezvous between a Soyuz spacecraft and the American Space Lab. Now, on the ground, the Cold War was going on, but up in space, these two labs joined in space. And there was this epic moment where they opened up the hatch of either side and they did this epic handshake in space. I think we need more of this at the moment, people uniting. And space really does that. From space, you don't see the divide. Space can be a really unifying force in people's lives. And of course, further collaboration has gone on. We've got the formation of the International Space Station and a project that I worked on, the James Webb Space Telescope, where you have countries and people from across the world collaborating together to find out more about the universe. And I must admit, this is the era that I've mainly worked in, this collaborative era. And I think it's been fantastic. But at the same time, decisions are made by committee. So sometimes we don't punch as hard as we could, push forward as much as we could, because everything is a slow progress, but gradual progress. But now, as I say, we're entering the era of commercialization. Now, space commercialization, from those initials, what are we going to do in space? We'll send Sputnik up to beep, to we can do surveillance. Now, space very much dominates our lives. From communication satellites, Earth observation satellites. I work on a number of satellites, looking at climate change, getting us an understanding of that. So it's it's gone a full circle, and space is helping humanity in so many different ways. And so the space industry is truly booming across the world. And it is a global phenomenon. And we've got companies like SpaceX, run by Elon Musk, but we also have companies here in the UK as well. One of the exciting things that's happening at the moment is we're talking about the capability of launching small satellites from UK soil. And so we're developing launch pads up in the Shetlands, but also down in Cornwall. And this would be a unique capability, the only one in Europe when this takes off the ground. So it is very exciting times. We've also got companies like Reaction Engines developing new spacecraft. This is one of their spacecrafts called Skylon. And to me, it looks as if it's come straight out of Dan Dare. It's the novelty of this spacecraft is that it's reusable. So it goes up into space, it releases, a cargo, passengers, whatever. But when it is traveling through the Earth's atmosphere, it sucks in oxygen from the Earth's atmosphere, and it can use that as fuel. The challenge is, as it sucks it in, it comes in super hot. And so the engines have a very complex mechanism to cool that fuel down so it's usable. So that's reaction engines happening right here in the UK. And it's quite interesting to look to the future, because I think with bodies like Reaction Engines, companies like Reaction Engines, the things that are happening with Virgin Galactic and Lockheed Martin up in the Shetlands, maybe we'll be getting an opportunity to go into space soon too. And as I go through my talk, I'll tell you how close that is to my heart. All my life, I've dreamed of getting into space, and it feels tantalizingly close at the moment. People are talking about space hotels, very expensive, but the possibility of staying in space. And what I love about a space hotel is it can be compact and Beiju, because in space you don't need to lie down on a bed. Usually a hotel room is dominated by the bed, but of course in space you can just Velcro yourself to the wall, and you can go to sleep that way. So I think there's a lot of opportunities out there for space development at the moment. But it's quite interesting to see, because at the moment it is very, very expensive, and only the very rich and famous can consider going out into space. But I think the same could have been said for air travel in the 1950s. I think in those days it was only the starlets and the rich and famous that flew around on aeroplanes. But I think no one anticipated EasyJet at that stage. But I think it's supply and demand. When more and more people wanted to do it, more and more people started providing flights, and the price came down. We've seen the same with hard drives. Initially, they were hideously expensive. The first IBM computer used by NASA was the size of a room. But with demand, more and more people wanting to use this technology, the price comes down again. So it's going to be very interesting to see what space travel does in the next 30 years. And then there are lots of plans afoot at the moment. And NASA's Artemis project, Artemis is designed to send people back to the moon. Rather embarrassingly, of the 12 people that have been to the moon, they've all been white and they've all been male. And so now NASA has promised that they want to send people back to the moon, but the people going back, one, there has to be sort of a female amongst the crew, and two, there has to be someone from an ethnic minority, and three, they're probably looking at disabilities as well. Now, I'm Black, female, and also I have dyslexia, so I keep on putting my hand up and volunteering, so we'll see if they take me up on the job. But it's quite exciting that now we're looking to go back to the moon. And it's quite interesting because we're not just looking to go back, we're looking to sort of potentially colonize the moon. Now, we've been talking about this for many years. Before the Apollo moon landings happened, we were talking about going to the moon and colonizing the moon. And in many ways, I thought we'd be there by now. But due to the cost, the hiatus, and the technical challenge of it, we haven't gone back yet. But now people like the European Space Agency are teaming up with Fosters and partners, people who are the architects that sort of designed the Gherkin, and looking at ways that we might be able to utilize the moon and build moon bases. And so one of the challenges with the moon is it's a very hostile environment. People think of the moon as very cold, but on the day side, it goes up to plus 150, and on the night side, it goes down to minus 150. So depending on if it's day or night, day and night lasts 2 weeks, a day lasts 2 weeks, and a night lasts 2 weeks on the moon. But depending on if you're in the day and night side, the temperature can be pretty crippling. And so they're talking about sort of sending 3D robots to actually use the lunar regolith, have an inflatable sort of a dome, and then use these 3D printing robots to actually scoop up the lunar soil and sort of 3D print that onto the inflatable to provide protection from radiation, from temperature, so that the future astronauts will be able to sort of live in comfort on the moon's surface and do some hopefully fantastic science. So these are the plans afoot at the moment. So we're looking to the moon, as they say, moon, Mars and beyond. And so it's exciting times for space. As I say, we have been speaking about this for many years, but it feels almost tantalizingly close at the moment. I mentioned moon, Mars and beyond. Other people have got their eyes on Mars. They've got Mars in their eyes. This is an artist's impression of a project that's happening in the UAE at the moment, where they're utilizing the sort of extensive desert they have and building sort of biodomes to try and work out what it would be like to live on Mars. Now, the temperature in the UAE desert is very, very different from the temperature on Mars, but it's dry, arid, and very inhospitable. So we can get some insight into what we might encounter if we go out to Mars. And many of these different countries and projects have long-term plans. Their celebration of their independence, the UAE were hoping that by 2117 they'll actually have a Martian base, and this is again some artist's impression of what this Martian base would look like. And the Martian base was called Peace, which I thought was very hopeful for the future. But at the same time, space brings up all sorts of ethical questions. One of the things that we're looking at the moment is sort of global internet access. Companies like SpaceX are launching satellites. Companies like OneWeb are launching satellites so that we can have global internet coverage. To me, this is incredibly exciting because global internet coverage means that people may be stranded in a refugee camp can connect to the internet and get work and sort of find ways out of their the devastating positions they're in. But at the same time, we're putting lots and lots of different satellites up there, and the whole challenge of space debris is going to be a big challenge for the future. At the same time, I like the idea of putting satellites up there that do Earth observation. With climate change impacting our lives in so many different ways, especially in the developing world, having satellites that help us monitor the effects of climate change and help mitigate against climate change, so that they have early warning systems. For instance, in Hurricane Katrina, a group of satellites called the Disaster Monitoring Constellation flew over the affected areas and were able to take photographs photographs and send them to sort of various NGOs so that they could actually work out from the images where help was needed and how you get to these people. So I think the space can do so much for us in so many different ways. But I'm also fearful of the space haves and the space have-nots. Some countries have enough money to get their foothold in space, and other countries are sort of looking to sort of use the data to get their foothold in space, but they've got other challenges to face. So how can we make sure that we don't have this sort of this polarized system where some people are sort of space, some nations are spacefaring and some nations aren't? And also, one of my big fears is that when we look here at planet Earth, and it does feel as if we've had a wild party here. We've had a wild party. We've woken up, surrounded by mess, and we're thinking, "Ooh, that's a bit messy. Let's go to the next planet and start again there." There are so many lessons we need to learn here on Earth before we start thinking of going out there. And also, what are we projecting out there? As humans, we seem to divide ourselves in so many different ways, sort of religion, race, there's all these differences. Will we be projecting those out there as well? When we get into space, will there be the UAE colony and the British colony? And will we be dividing people up again? Space has the power to unify. Can we not learn the lessons? And as my beautiful medal said, think for yourself, but act for everyone. I think space truly needs to be for everyone. So where do we go from here? Well, I have this sort of vision of space being sort of wonderful and space being truly for everyone. But it is a case of Houston, we have a problem. Because at the moment, we don't have enough space practitioners out there. Here in the UK, we have a deficit of how many people are actually doing STEM subjects. And there's a horrible statistic out there that says fewer than 15% of 10 to 14-year-olds are considering careers in STEM. And so I have this lovely, shiny vision of the future of space where humanity is united. But at the moment, we have a skill shortage and we're not getting enough people practicing STEM. And so it's quite interesting because this lecture is sort of themed around International Women's Day. And the hashtag for International Women's Day this year has been breaking the bias. And if we look, there is some serious biases in STEM. At the moment, 28% of ethnic minority men are less likely to work in STEM than white guys. 29% of people who identify themselves, I'm going to get this wrong, LBGTUA+, sorry, dyslexia, opt out against having a career because they think they might be discriminated against. And only 22% of women are represented in sort of a core STEM workforce. So we have a whole series of diversity issues in STEM that we need to take on and challenge. But at the same time, back in 2019, before the coronavirus had really hit the UK, there was a moment of joy because there was a celebration. Because if you looked at the number of people taking A-level biology, chemistry and physics, for the first time since records began, there were more women or more girls taking these subjects than boys. And so it was, yes, a sort of congratulatory slap on the back and yes, we're getting there. If you looked at the results, it was very polarized. Because if you looked at the subjects, there were many people sort of going into law, biology, and sort of medicine, subjects like that. And I think it's quite interesting to look at medicine because in medicine, more girls are going into medicine than boys. So this is a success story. A few years ago, I was listening on Radio 4. I'm an insomniac, so I often listen to sort of radio programs at night. But listening on Radio 4 to the struggle that women had to become qualified as doctors. A number of women, sort of like Elizabeth Garrett Anderson and Sophie Jex Blake, they were trying to get qualified. But as people were saying, women don't do sort of medicine. Women can't do this sort of thing. And so they struggled, they went across the world, they tried to find ways of getting qualified. But in 1865, the first woman, Elizabeth Garrett Anderson, got her qualification. That was 157 years ago. And now we can see more women going into medicine than men. So change can happen. The problem is we don't want it to take as much as 157 years. But as the change is happening, we still have a deficit in certain areas. If you look at sort of women consultants, we are still underrepresented. And so although more women are going into medicine, more women aren't getting into the upper echelons of medicine. And so we still have this sort of deficit happening. And it's trying to work out what we can do about it. And the deficit is very clearly seen if we go to the other end of the scale and look at subjects like physics, mathematics, engineering, and IT. Here, especially in sort of computing science and IT, we have a very bad deficit of women. And we are short of people with these skills here in the UK and across many parts of the world. So if we can address this problem, we'll have the population we need, we'll have the workforce we need. And as AI and subjects like this come in, we need to have more people working in these areas. And it's quite interesting because looking at the gender pay gap, I was just doing some research the other day and I saw the gender pay gap in the space industry, one small step for man, one giant pay gap for women. And I was absolutely horrified that this is happening. So how do we make the change? Well, it's quite interesting because I think the need for change is definitely now. And so how do we break that bias? Well, as Samira very kindly said, over the past sort of 14, 15 years, I've been going out and speaking to people. And one of the things I first did is I thought I'll go to girls' schools and speak to girls and sort of encourage them to consider careers in STEM. But it turns out that many girls in girls' schools are more likely to go into STEM than girls in mixed schools. Now, I speak to everybody and try and get everybody excited about science. And the way I do it is I use a three-pronged attack. Firstly, I want to talk about sort of role models. Secondly, I want to talk about sort of the relevance. And thirdly, I want to talk about wonder, because the sort of things we're doing in STEM is breathtaking. Listening to sort of last year's lecture, looking at sort of the hunt for the vaccine, how it all came together. That is sort of, to me, it's like poetry in motion, but it's using the scientific method to solve problems and sort of take on the global challenges. Now, one of the things that I found as a child is growing up, I was convinced that in the area of astronomy, that all astronomy sort of started with white guys in togas, because it all seemed to start with the Greeks. And it wasn't until I got older that I started doing sort of more research and finding out that astronomy is the heritage of the world. I think astronomy is what unites us together. When we go outside and sort of, actually, I think I can just about see the moon from here. When I go outside and I look at the moon, I am following it in the footsteps of our ancestors across the world. And this is a short snippet of a UNESCO astro timeline. And I like to call it, who knew what when, because it just shows different cultures across the world going back 5,000 BC. Who knew what when, how different cultures have sort of built amazing monuments, drawn cave paintings sort of depicting the night sky. So it is truly the heritage of everybody. And I think that's a message I really like to get across, because sometimes when I go out to schools, I think, you're a black woman, why are you doing astronomy? That's not for us. Astronomy truly is for everyone. And our heritage and culture shows that. And we can see that in sort of some of the amazing monuments out there. And this is a part of a stone circle in a sort of the Namibian desert. It's called Nabda Playa, and it's sort of 7,500 BCE. Sorry, dyslexia there again. And it's a stone circle, sort of in Africa, the oldest stone circle in the world, older than Stonehenge. So again, we have that heritage. Looking at sort of things like astrolabes, Arabic communities made these beautiful astrolabes. And to me, they're a combination of art and science. They do some amazing science. You can sort of look at how stars rise and set, but at the same time, they are works of art in themselves. If we look at sort of the Central American culture, the Mayans, the Aztecs built these wonderful monuments. They were aware that of the sort of the equator of the Earth. They were aware that the sun was the center of our solar system, and so they have had knowledge that it sort of comes and goes, waxes and wanes. But again, it is the heritage of all of us. And so, but I think we also have an issue with the traditional view of a scientist. When I go out to school kids, I like to show sort of this series of pictures. This is a chap called Ernest Rutherford, and he's one of my heroes because he was quite clumsy and untidy like me. So I think we had a lot in common. But his work, the work that he did at the Rutherford laboratory, was fundamental to our understanding of an atom, how an atom works, and what an atom is made of. But again, when I show this picture, this is sort of what people expect a scientist to look like, because he's white, he's male, and he looks very, very serious. And that's what people expect a scientist to look like. People think that scientists have brains the size of small planets. And when you've got a brain that big, you've got no time for fun and games. You're just here to do serious work. Another picture, which I like to show the kids, is, of course, Albert Einstein, the granddaddy of modern physics. And people ask me, why is he sticking his tongue out? And the absolute answer is, I have absolutely no idea. But again, it's sort of a quintessential view of a scientist. He's whiting his male again, but he's not looking quite so serious. But often his Einstein-like characters depicted in sort of things like James Bond films, striking a white cat, Mr. Bond, we're going to take over the world and turn it into jam. Sorry, I just love doing the laugh. So again, this is sort of a quintessential view that we have of scientists. So when I go out to schools and speak to school kids, I like to show this picture and say, spot the scientist. Because this is my husband and I on our wedding day. And I'm wearing a wedding dress that I designed myself. And I like to say, which one do you think is the scientist? And the point is that we're both scientists and engineers. And with that, not because we have brains the size of small planets, because unfortunately, very unfortunately, I don't. But it's because we are inquisitive. We want to find out things. And in many ways, we want to change the world. And so this is why I think we need so many role models. And that's why I'm so proud to be doing this Rosalind Franklin Medal lecture, because Rosalind Franklin is an amazing role model and a role model that needs to be celebrated. And I found this sort of a snippet just to fill people in about her life. So I'll play this short video.
Story. Rosalind Elsie Franklin was born in London in 1920. She wanted to be a scientist ever since she was a teenager, which wasn't a common or easy career path for girls at that time. But she excelled at science anyway. She won a scholarship to Cambridge to study chemistry, where she earned her PhD. And she later conducted research on the structure of coal that led to better gas masks for the British during World War II. In 1951, she joined King's College to use X-ray techniques to study the structure of DNA, then one of the hottest topics in science. Franklin upgraded the X-ray lab and got to work, shining high-energy X-rays on tiny, wet crystals of DNA. But the academic culture at the time wasn't very friendly to women, and Franklin was isolated from her colleagues. She clashed with Maurice Wilkins, a lab mate who assumed Franklin had been hired as his assistant. But Franklin kept working, and in 1952, she obtained Photo 51, the most famous X-ray image of DNA. Just getting the image took 100 hours. The calculations necessary to analyze it would take a year. Meanwhile, the American biologist James Watson and the British physicist Francis Crick were also working on finding DNA's structure. Without Franklin's knowledge, Wilkins took Photo 51 and showed it to Watson and Crick. Instead of calculating the exact position of every atom, they did a quick analysis of Franklin's data and used that to build a few potential structures. Eventually, they arrived at the right one. DNA is made of two helicoidal strands, one opposite the other, with bases at the center like rungs of a ladder. Watson and Crick published their model in April 1953. Meanwhile, Franklin had finished her calculations, come to the same conclusion, and submitted her own manuscript. The journal published the manuscripts together, but put Franklin's last, making it look like her experiments just confirmed Watson and Crick's breakthrough, instead of inspiring it. But Franklin had already stopped working on DNA and died of cancer in 1958, never knowing that Watson and Crick had seen her photographs. Watson, Crick, and Wilkins won the Nobel Prize in 1962 for their work on DNA. It's often said that Franklin would have been recognized by a Nobel Prize if only they could be awarded posthumously. And in fact, it's possible she could have won twice. Her work on the structure of viruses led to a Nobel for a colleague in 1982. It's time to tell the story of a brave woman who fought sexism in science and whose work revolutionized medicine, biology, and agriculture. It's time to honor Rosalind Elsie Franklin, the unsung mother of the double helix.
So I just wanted to mention that because as I'm giving the Rosalind Franklin lecture, I thought it'd be nice to sort of celebrate her life and her work. But we have some fantastic role models out there. This one here is a bust of a woman called Ed Hedu Anna. Hers was the first female name to be written in the history books, and she was the moon goddess of the city of Babylon. And her poetry still survives today and is studied today. And she talked about sort of, measuring arcs across the sky, and how women and men can sort of, do astronomy together and understand what's going on out in the cosmos. And she's a sort of a fantastic role model, and it's going back sort of over 3,000 years. In the middle here, I've got Jocelyn Bell Brunel, another woman who was unfortunately, I believe, cheated out of a Nobel Prize. She discovered an amazing object in space called a pulsar. When some stars collapse, some large stars collapse, they form these sort of really dense objects. I heard Jocelyn describe it once as if you take the population of planet Earth, so about 7 billion people, and squeeze them into a teaspoon, that's the sort of density we're talking. Now, these stars spin very fast, and they send beams of radio waves out into space. And if one of these beams sort of spins passes Earth, you pick it up as a beep. So what Jocelyn found is something going beep, beep, beep in space. Now, when she did this, she sort of presented the data to her supervisor, and her supervisor was a little disparaging and sort of suggested, "Oh, Jocelyn, have you discovered little green men?" So Jocelyn realized that having just one example wasn't enough. So she went on to find other examples, and then sort of looked at and sort of understood that these are pulsars. Now, unfortunately, her supervisors went on to win the Nobel Prize, and she wasn't even aware of it. She just got a phone call from a friend to say that, they'd gone on to win the Nobel Prize. Now, I must admit, if I was in Jocelyn's position, I would be bitter and twisted about that. I'd be sitting in the pub, with my drink, that Nobel Prize, it should have been mine. But Jocelyn I've met many times, and she says, no, if you win a Nobel Prize at the age of 27, what do you go on to do with your career? So she's an amazing woman and a sort of a joy to meet. And I think I'd be bitter and twisted, but she has gone on to have a fantastic career, including being president of the Institute of Physics. Next, I've got Marie Curie. So many people are more familiar with Marie Curie's work, as she went on to win 2 Nobel Prizes, one in physics and one in chemistry. And her work was sort of, again, very cutting edge. But one of the things I love about this photograph is she won 2 Nobel Prizes, and one of her daughters went on to win a Nobel Prize as well. I always feel sorry for the other daughter that didn't get one. Down here on the left-hand side, I've got a woman called Margaret Burbidge, and she was a solar scientist looking at the sun and trying to understand the mechanisms within our local star. Unfortunately, she had various theories which she wanted to test, but she wasn't allowed to get telescope time. Her husband, who was a theoretician, was able to get telescope time. So although he didn't need telescope time because he was a theoretician, he'd apply for telescope time and then give it to Margaret. So it's quite interesting to see sort of how these women have sort of overcome hurdles. And these are sort of women who have been the pioneers that have enabled us to move forward today. Down in the center bottom is a woman called Gladys West, and her work was to look at the shape of the Earth, and her work has enabled us to have accurate GPS sort of as we run around the planet. And then on the I'm really bad at this. On the right-hand side bottom is Katherine Johnson, whose work was celebrated in the film Hidden Figures, and I'll talk about that in a little while. So we've come a long way. I remember Jocelyn saying that when she used to study physics, I think up in Edinburgh, people used to bang the table when she came in because she was the only female. We've come a long way, but we still have a way to go. But also, I think in terms of actually getting sort of more people into science, we have a bit of a PR job as well. And I think this sums up the problem.
I'm worried about little Dilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
Oh, the part that worries me is he used the components to build a ham radio set.
Oh, dear.
Is that bad?
Normally, I'd want to run an EEG on him, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical. And Utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer.
No!
There.
So I think that's some of the challenge we face. The idea of being a scientist or an engineer is still a very nerdy one. Lots has been done to sort of try and break down that image, but still, I think again we have a way to go. So when I do sort of science communication, and when I'm trying to sort of break down the biases, what I do is I like to tell sort of the story of my life. This is a picture of me when I was about 3 years old, and I would have loved to have a picture of me epically looking up into the night sky, but no, I've actually dropped my ice lolly on the ground and I'm trying to pick it up before my parents can catch me. So not the most glamorous of starts. But for me, I got the space girl right from the get-go. I heard about people like Yuri Gagarin, the first person into space, and Neil Armstrong, one small step for man. Those were the words ringing in my ears as I grew up, because I was born in 1968, and in 1969, Neil Armstrong took his giant leap. In fact, it said that I was taking my first wobbly steps as Neil Armstrong took his giant leap. So these were the people that I was sort of aspiring to growing up. And it turned out that I used to watch sort of things like the Clangers, and the Clangers were a bit of a gateway drug that lead on to sort of science fiction and sort of Star Trek. So growing up, I was sort of, everywhere I go, I always have a little clanger with me. So growing up, I was watching the Clangers, I was sort of watching Star Trek, and the idea of getting into space sort of came to me, and it stuck with me ever since. In fact, I can't remember a time where I didn't want to go into space. And one of my absolute heroes is Lieutenant Uhura, because growing up in the 1970s, I didn't see many Black people on TV. So Lieutenant Uhura was the communications officer. She was amazing. And I thought, yes, when I grow up, I want to go out into space. I want to meet the aliens, and I want to be just like Lieutenant Uhura. Now, I had all these crazy dreams sort of going on in my head, dreams like going out into space and seeing the curvature of the Earth, just as Yuri Gagarin did, going to the moon and walking next to the footsteps of Neil Armstrong, sort of going out and meeting the Clangers, and then going out beyond to what we can now call exoplanets, planets going round other stars, just as they did in Star Trek. So these were my crazy dreams, but it all went horribly wrong for me when I went to school. It's because what I didn't know at the time is, well, first of all, I attended 13 different schools, but also I have a condition called dyslexia, which I've mentioned a few times. And I see dyslexia as my superpower now. It gives me the ability to see sort of, literally off the planet. It gives me the ability to sort of, empathize and communicate and do many of the things that I find so useful in my work today. But of course, when you first start at school, it's all about reading and writing. And so the dyslexia was, it really sort of, it made me feel as if I wouldn't be able to fulfill my crazy dreams. But I remember sitting in a science lesson one day. Generally, I was at the back of the class with the safety scissors and the glue. But in science, I paid a bit more attention. And I remember the teacher asking, if 1 litre of water weighs 1 kilogram, what does 1 cubic centimetre of water weigh? Now, one of the other sort of superpowers that you get with dyslexia is logic. And I worked out that 1 cubic centimetre of water is a thousandth of a litre, and a thousandth of a kilogram is 1 gram. So 1 cubic centimetre of water should weigh 1 gram. It made sense. And so I put my hand up to answer. So, yeah, I think I've got this. And then I looked around the classroom and no one else had their hand up. So I put my hand down. But the teacher was sort of surprised, Maggie answering a question. So she encouraged me to put my hand back up. I did. I answered the question and I got it right. And at that moment, it was as if heavenly angels started singing. It thought, because it was that moment of confidence. Oh my goodness, no one else knew this and I did. Where will that lead me? And so from that early beginning, I sort of got the confidence and I started paying more attention in class, especially in science classes. And I used to study with my father, would go to the library and get books. And so my grades started going up in science and then in other subjects too. And I've learned that, so in times of change and uncertainty, so look for opportunities. One of the opportunities that came along was when I was, by going to 13 different schools, I had an opportunity. I went to a school and they said, what stream should you be in? Sort of a lower, middle or upper. All my life I'd been in the lower stream, but I took a gamble and I said, yeah, upper stream, put me in the upper stream, always in the upper stream. It was a lie, but I thought that if I was going to try and fulfill my dream, I'd be nice. I need to be in the upper stream. So they put me in the upper stream, and I must admit, I worked my socks off. For 2 years, I didn't watch any television. I just sort of studied. And that led to opportunities of me getting sort of GCSEs, 10 GCSEs, 4 A-levels. And that led me to going to university, get a degree in physics and a PhD in mechanical engineering. So I think sometimes by having that crazy dream, it helps you focus and sort of concentrate and look for opportunities to get you closer to your dream. And that's the same with the human computers at NASA at the time of the Apollo moon landings. They were segregated. They had the sort of the coloured computers and the white computers, and never the two should mix. And in the film, it shows that Katherine Johnson running to the loo because the Negro loo, as they put it, was in sort of another building. So it's sort of it was a trying time, and so it's quite interesting to sort of see what they achieved, because one of the things that Katherine Johnson did is she went to borrow a book on Fortran because the IBM computer was going to come in and take over their jobs. So she went to get this book on Fortran, but unfortunately it was in a white library, so she wasn't allowed to take it out. So she acquired it. I think it just fell into her bag or something. She took it home, taught the coloured computers how to use Fortran. And then in the end, the coloured computers and the white computers were merged, and she was the supervisor for both. So again, looking for those opportunities can take you to places you'd never thought possible. And I think that's definitely been the case for me. Having a crazy dream and looking for opportunities have enabled me to do things I would have never dreamed were possible. This is a picture of my daughter and my daughter is carrying a model. And the model is actually a model that was used to make a very special episode, well, very special to me, of the Clangers called The Visitor. So that's me sitting, standing next to Major Clanger. And if you go on YouTube, this episode of called The Visitor is available on YouTube to see. And it is my crazy dream of meeting the Clangers coming true. And when I watched it, there were truly tears streaming from my eyes. And so I think by having a crazy dream, I may never get the opportunity to go into space, although I'm optimistic, I still want to do it. But it's led to a career which I would have never thought possible, a very, very varied career. I've got to do things which I would have, which just sort of didn't seem possible. My first job was working for the Ministry of Defence. Now, I had some qualms about this because especially growing up, I saw myself as a pacifist. So working for the Ministry of Defence was quite a conflict for me. It didn't seem to add up with sort of who I was. But at the same time, I was able to work on sort of defensive mechanisms. So my first job was working on missile warning systems. So to try and warn a pilot if a missile is coming. And I love to show these pictures to kids because in this picture, I'm sort of standing with a huge belt around my waist. And for some of the time, what I was doing was taking images of missiles running down tracks. And to do this, I'd actually sort of have this belt on, which was attached to the floor of the aircraft, which I open up the back door of the aircraft, and I would literally hang out of the back door of the aircraft with a camera, taking pictures of missiles going down a track. To me, it felt more like sort of James Bond than sort of a standard image of a scientist. And so I like to show the sort of variety of things we can do as scientists and engineers. And next job, I got an active promotion to work in a landmine detection, still for the Ministry of Defence, but trying to tackle, again, a global problem. This is a map of just some of the places across the world which still have the blight of landmines. At the time I was doing this, Princess Diana was doing some amazing work promoting the problem. And the United Nations have said that at the current rate of detection, it's going to take over 1,000 years to clear all the landmines that are out there. So I find this sort of, it seems an odd thing to show to kids, but I think it's important because science and STEM can be used to do amazing things, help us understand the universe, help find vaccines for pandemics, but at the same time, they can be used for devastation. And so that's why I think everybody has to have an awareness of STEM. So as a society, we can make the right decisions. And going on, I got one of my favorite jobs as a child. I made my own telescope mirror by sort of taking two pieces of glass and sort of rubbing them together while watching Star Trek. My telescope was only about 150 millimeters across, but later on I got to work on one of the largest telescopes in the world. This is the Gemini telescope in South America, and this is the Gemini telescope in Chile, and then there's another Gemini telescope in the Northern Hemisphere, which represent the Gemini twins. The Northern Hemisphere Gemini is not that northern, it's actually in Hawaii, which is a great sort of situation because you can sort of lie on the beach in the day and then sort of do astronomy at night. It's a winning combination. And so yes, but this is the Gemini telescope that sits in South America, and it is just like a cathedral to science. It is beautiful. When the sun sets, you're up above the clouds, the sky goes a deep purple and stars start to appear. So working here was, it was just quite fantastic. And this is the heart of the telescope mirror. And this telescope mirror was 8.1 meters in diameter. So you can have a sort of little telescope. My telescope was 150 millimeters across. This one is 8.1 meters across. So 8.1 meters of light gathering power. But what I was making for the telescope was an instrument called BHROS, bench-mounted high-resolution optical spectrograph. And with this, we actually gather the light by the telescope, feed it via a fiber into this instrument, which actually stretches the light out into its component colors. We were making sort of rainbows in the lab. And with this, we can actually study and understand the star that we're observing. So these absorption bands represent chemical reactions that are happening in the heart of the star. By looking at the fingerprints of the bands, we can see if the star is moving towards us or away from us. So this was one of my favorite jobs because it enabled me to look into the heart of stars. And it was a segue to me working in the space industry. And I've worked on a number of different instruments, things like the James Webb Space Telescope, which was sort of launched on Christmas Day, but also instruments like this. This is the Aeolus satellite, which sends pulses of UV light into the atmosphere. And this light enables us to understand and get a better understanding of climate change. So it's, again, a powerful telescope helping us better understand our planet. And this was the front end unit that me and my team made, and it sort of sits in the telescope, at the heart of the telescope, and sort of gets the analyzed light and tells us how the wind is moving. I mentioned the James Webb Space Telescope. I was biting my nails on Christmas Day as it went up. And the James Webb Space Telescope sits 1.5 million kilometers away from Earth. And so it's been quite worrying. It's sort of an amazing space telescope, a huge space telescope, a 6.5 meter mirror, but it's all folded up. And as it's sort of gone out into space and got to Lagrange point 2, this point is sort of looking into deep, dark space, it's slowly but surely unfurled, and various mechanisms have sort of been deployed. And so far, so good. It's looking fantastic. So I think we're going to be getting some fantastic data from this in the future. Actually, I'm just going to move on from this and just sort of talk about sort of lessons that I've learned. And I think having a crazy dream and thinking big is so important. I mentioned sort of the moon landings earlier. That was a crazy dream that Kennedy sort of threw out there. But I think by having that crazy dream, people got on board. And I think more and more of us should be thinking big. I was very fortunate to be invited to COP26 last year, and to sort of hear about the challenges we're facing, and hearing people from Kenya and places like that saying, we're living with climate change now. It's not something in the future. We need to sort of find mitigations now because it's happening. And so I think we need to come together as a world, but we also need to be sort of using space as a tool to help with the mitigation for climate change. And I think that's the key, is coming together, is putting the differences aside and sort of working out what we have in common. Because when we do come together, we can achieve the seemingly impossible. And in terms of space and science, I've seen this happening. I mentioned the Gemini telescope that sits in Chile. These are 4 telescopes called the VLT, the Very Large Telescope. And they sit in the Atacama Desert, the driest place on Earth. And it's 4 8-meter telescopes that can be combined to work together, that give us a very clear image of space. But now what we're building is the ELT, the extremely large telescope. Whereas the VLT are 4 8-meter mirrors, the ELT is 1 39-meter mirror. And that's a sort of a shadow of the VLT there next to it to show how big the ELT is. And there it is, sort of next to Big Ben, to put it into perspective. This has been built as we speak, and they chopped off the top of a mountain and they're building this telescope. And with this, we should be able to get amazing views of the cosmos. But the telescope I hope to see in my lifetime, we simply call the OWL. And that stands for the overwhelmingly large telescope. A telescope where the primary mirror is the size of a football pitch, 100 meters in diameter. So when we focus and we work together, many countries coming together, we really can achieve amazing things. Like this image taken by the Event Horizon Telescope. This is an image of a supermassive black hole. And we believe that a supermassive black hole sits at the center of every galaxy. Now, black holes, their gravity is so dense, not even light can escape. So what we're seeing is the shadow of the black hole, but we're seeing the radiation from particles as they fall into the black hole and release light before they get to the event horizon, and then not even light can escape. And this was a collaboration of different telescopes across the world, pooling their data, taking sort of data simultaneously, correlating it together to enable us to get the image. And so this is an exciting time. Also, we're moving away from traditional astronomy. In the past, when we did astronomy, we could only use the electromagnetic spectrum. That's because electromagnetic spectrum, that's X-rays, gamma rays, visible light, UV, infrared, radio waves. The electromagnetic waves are the only thing that could travel through the vacuum of space. But one of the predictions that Einstein made was something called gravitational waves. And we can pick these up when massive objects like neutron stars collide together and send ripples out in space and time. When Einstein predicted this over 100 years ago, we had no way of measuring them. But by combining efforts together, we've been able to develop technology that enables us to measure gravitational waves. Now, to do this, we are talking about the science of the virtually impossible, because we're looking for an accuracy of 1 millimeter in 4.28 light years. And so that's looking at 1 millimeter in effectively 40 trillion kilometers. It sounds impossible, but we can do it because of this very distinct signature of the gravitational wave, because it elongates space, time in one direction and then elongates it in the other. And so by using that signature and detecting that signature, we are able to measure this tiny, tiny shift as a gravitational wave passes through. And to do it, we have big instrumentation. This is the sort of LIGO gravitational wave detector, and each of these arms, which are sit perpendicular to each other, are 1.5 kilometers in size. So we're talking about a huge instrument to detect these tiny, tiny waves. But science is now not done just by scientists. One of the challenges we face is the amount of data we get. And so I've got a short video here on sort of collaborative science.
60-second adventures in collaborative science. Number 1, citizen science. Since the study of science began, it's been expanding and evolving faster than you can swipe left. Today, scientists are using technology that would have blown the minds of their predecessors. But the problem is that things like our swanky new telescopes mapping space are producing so much information that even our swanky modern computers can't handle it. Then, in 2007, Chris Lintott and the team at Galaxy Zoo had the idea of asking volunteers if they could help sift through images from space. And it worked. People from all over the world helped out and not only classified and even discovered new galaxies, but spotted and named other astronomical objects as well. This project soon became a collection of projects, the Zooniverse, ranging from decoding ancient manuscripts to spotting penguins in Antarctica. All you need is an internet connection, and everyone in the world can become a collaborative scientist. Now, that is mind-blowing.
So I love this because it feels to me as if we've gone full circle. As in the ancient times, people were stepped outside and sort of looked up into the night sky. Now, sometimes science seems to be very distant. It was only done on big telescopes, but now everybody can do sort of space and astronomy and many other sciences too. It's sort of science for the masses, and it means that everybody can be involved in the journey we're making. And it's been quite a journey. Through scientific discovery, we've sort of got a better understanding of our place in the universe. We think from sort of studying stars that the universe began with a big bang, the creation of space, time, and all matter in the universe, sort of spewing out and creating galaxies and forming sort of over 14 billion years ago. We know that we believe that our solar system was formed because in our galaxy, the Milky Way, a passing sort of a cluster of stars passed through our galaxy, disrupted sort of the nebula where our solar system formed, and this nebula started to sort of clump together and form our solar system. We think our solar system, started as this swirling ball of gas, which sort of picked up speed and momentum. Particles started colliding and made bigger and bigger and bigger particles. And eventually our solar system was formed. But of course, at the heart of our solar system is our local star, the sun. And enough matter had to be accreted onto this star so that the process of fusion could take place, because the temperatures and pressures were hot enough that the E equals mc squared particles coming together, atoms coming together to sort of form a higher elements could happen, but then releasing energy in that process, which is what we see as the electromagnetic spectrum, which we detect in astronomy. And then sort of looking at how how the moon, the formation of the moon helped sort of trigger life here on Earth. That we believe that life started almost as soon as it could, when temperatures and pressures on our planet were able to have life seemed to start. And life went through this whole process, the single cellular organism, then multicellular, this whole process of getting the division within cells as different things doing different processes. Then we go into multicellular organisms, still all at the moment still in the sea, but how this evolved to make humans today. But now we're looking beyond our solar system and looking for potentially life out there. These exoplanets, which I mentioned earlier, we're finding more and more of them. And this is an artist's impression of what one of these exoplanets, what might be the view from one of these exoplanets. And I just love things. I love science fiction. So this is the stuff of science fiction. But it's happening today, and we're detecting more and more of these exoplanets, and these planets going around distant stars. And we're finding weird planets like hot Jupiters, close to their sun. And we're finding Earth-like planets. We detect them in all sorts of different ways. Planets themselves don't give off any light, and so we see the planets in the night sky in our solar system just because they're reflecting light from the sun. But when we look out there, detect an exoplanet, the main method we use is when an exoplanet goes in front of the star, the light from the star will dim by a small amount, and we can actually tell a lot about the exoplanet when that happens. And so we're using these different methods and finding Earth-like exoplanets, which sit in what we call the Goldilocks zone, or the habitable zone, because it's not too close to the star, not too far away, but just right to have liquid water, which seems to be one of the fundamental things we need for life here on Earth, and maybe one of the things needed for life out there. So we're looking out there and we're learning more lessons. And my biggest lesson I think I've learned is that even the craziest dreams have come true. I've mentioned some of my crazy dreams, but for me, it's always been that desire to get out there. Star Trek promised so much, and yet we haven't made it. We haven't reached the stars yet. But maybe crazy dreams can come true. And one of my crazy dreams came true, and my crazy dream came through due to Samira. So Samira, a thank you from the deepest part of my heart, because this is one of my favorite pictures of all time, because it's my lovely daughter Lauren. She's carrying a clanger, and the person I'm sitting next to is Lieutenant Uhura. So Samira, you enabled my craziest dreams to come true. But I say my dreams are still very crazy. And so it's I've got that milestone. I've met the clangers, I've met Lieutenant Uhura. Now I want to get out there. And it's an exciting time because we've been detecting planets like Proxima b. Proxima b is an exoplanet which is about the size of Earth. We don't actually know what it looks like. This is just an artist's impression, but it's about the size of Earth, and it's going around our next door neighbor star. So if I want to go to an exoplanet, that seems like the best bet. But if we look at it, it's quite a challenge to get there. The distance between our solar system and Proxima Centauri is 4.28 light years, which is the 40 trillion kilometers I was talking about earlier. And so using current technology, it would take, traveling at about 16 kilometers a second, it would take 76,000 years to get to this next door neighbor's star system. So it doesn't feel as if I'm going to get out there anytime soon. But as I say, crazy dreams can work. And the late, great Stephen Hawking was championing a new project called Breakthrough Starshot. And with Breakthrough Starshot, we wanted to use a new method of getting out into space. It has been used locally, where we actually use photons from the sun to hit what we call a solar sail. And when the photons transfer their momentum, they can accelerate that solar sail. What we want to do now is not use light from the sun, but use light from right here on Earth. So set up a bank of lasers, fire them into space, and actually they hit the solar sail, and they can accelerate this solar sail to 1/5 of the speed of light. Now, for any Trekkies out there, that's about warp factor 1/4. But if we do this, we should be able to travel to this next door neighbor star, not in 76,000 years. At a fifth of the speed of light, we can get there in just 20 years. So my crazy dream is getting closer. But the challenge is the first probe we send out there, it can be weighed no more than 1 gram. So at 1 cubic centimeter of water. And we have to include all the technology we need on that 1 gram. Also, it will be a flyby. We can accelerate to the fifth of the speed of light, but we can't slow it down. So it will fly by these exoplanets very quickly, grabbing as many pictures as they can, and then beaming them back to Earth. But it means that I'm getting that bit closer to my crazy dream. And so now we are finding that's a planet in our next door neighbor solar system, but we're finding more Earth-like planets out there. And now we can actually use techniques where we can actually look at the atmosphere of these exoplanets, and we're finding planets with water vapor in their atmosphere. Maybe in the near future, or sometime in the future, we will find life out there. We may find a signature, a biosignature that will be a strong indication that there is life out there. But when we do that, that will change us totally. There is always the adage, did we create God or did God create us? If we find life out there, how will that make us feel? Sometimes people feel that we have a God because there's life here and there doesn't seem to be anything else out there. So if we do find life out there, how will we interpret that? And so finding out we're not alone could be quite groundbreaking. So I think we live in exciting times. I think we should be looking wherever possible to harmonize, to work together, to put aside differences. That's what space gives us, that global view of humanity. Let's have a crazy dream. Let's be bold, aim high, and love every second. It's worked for me. I think it can work for you too. Thank you so much for listening, and sorry for going over. I'll stop sharing.
You never need to apologize, Maggie Aderin-Pocock, for taking us into the cosmos like that. That was amazing. And I remember that day with Uhura very well. And I wear my hoop earrings forever because she's also the woman I want to be. So we'll have to compete who gets to be here. I think you win. I have one very brief question I want to pick up from your lecture, and then I want to go to the wonderful questions that have been submitted. So thank you for just such an inspiring conversation. You mentioned early on that the challenge of collaborative working, which is the way space science is done now. And you said that, and this is your word, we sometimes it doesn't feel like we don't punch as hard as we could, which I thought was a really interesting observation. Could you just tell us a bit more?
Yes. I mean, you put this from this perspective that I've always desired to get out into space. And I think one of the challenges is when we work collaboratively, we work by committee. And so if you take something like the sort of the moon landings, it was sort of almost an individual saying, yes, we're going this way. And sometimes I think to make great leaps forward, you maybe need that. When things are sort of done, okay, well, let's sort of things are done slowly and gradually, and there is a place for that. But I think sometimes you need sort of maybe the visionary. The visionary can sometimes get muddled up with the dictator. So I'm slightly nervous about this.
Yeah,
I do think sometimes you need, and it's quite interesting because something like SpaceX with Elon Musk, he is sort of a pioneer. He's sort of looking forward, but at the same time, there are ethical issues to be to be contended with. And I think that's the challenge with the loner. They see the vision, but sometimes they don't see the bigger picture. And so it is, I think, a balance between the two. But one of the things I think we so need at the moment is better space regulation in terms of sort of putting satellites out there, space debris, and how we utilize space. Most of the space legislation was written in the 1950s when we were just taking our first steps out there. I think we need something more robust and sort of something that isn't voluntary, something that people sign up to and stick to, because it is exciting times, but we need to make sure we do it properly. And I do have this fear that there's the haves and the have-nots, and then also that someone just runs off and sort of says, we're doing this.
I know, well, like with China, with some of that space junk. I mean, there's been a question submitted about space junk, but you kind of hinted it is you just need more regulation. Let me dive into some of these amazing questions. So this is submitted by 12-year-old Hayden in Northern Ireland. Hi, Maggie. Thank you for inspiring me. What are you most excited for in new discoveries in space? As a planetary defense ambassador, I'm excited for more asteroids.
Oh, so asteroids. I find asteroids very exciting. So I think for me, it's funny because when I was younger, I was really interested in astronomy, but astronomy just seemed too far away. So I became a space scientist because it was much more local. And asteroids, I think, are incredibly exciting. It's again, we need to learn lessons. As we sort of look at planet Earth and populations grow, and there's sort of more demand, and we create more things. There is a feeling or a worry that we will run out of resources here on Earth. But we live in a solar system, and the asteroid belt is sort of some of the detritus left behind at the formation of the solar system. Sometimes some people think it might have been a planet that formed but then got smashed up. But we have this sort of asteroid belt that sits between Mars and Jupiter, and there's resources there. There's sort of we could do asteroid mining and do all sorts of things. But again, it has wonderful potential, but let's learn the lessons. Let's not waste and exploit. Let's try and do it carefully. So I think that's the thing with space. There's so much potential, but let's try and do it carefully. So I think if you're interested in asteroids, they will be a very, very interesting thing to study in the future, looking at their origin, because they're like time capsules. They tell us about the early solar system and how everything was formed. So I think you've got a good career there ahead of you.
Excellent. All right, another question. This is submitted by Amanda, but she's thinking of her 14-year-old daughter who wants to be an astronaut or work in the space industry. Where are the best places in the UK to study space sciences?
Oh, so there's a number of places to study, but also I need to be very clear, because people think if you're working in space, you need to I took sort of the very traditional route. You've sort of got a degree, physics, got a PhD, so mechanical engineering, which have been very useful in terms of sort of building instrumentation. But the space industry is an industry, and so we're looking for we're looking for scientists, we're looking for engineers, we're looking for lawyers. I was talking about the challenge of sort of space policy. We need different people from across the board. We need marketing, we need artists to interpret what we see. So there is the very traditional route of sort of going, and is she sort of into STEM? Perfect. Great places to study. Oxford, Cambridge, Leicester. I am a great Imperial College close to my heart. There's a great sort of a space department at Imperial. So there's many places to study space. And also when we start doing these sort of local launches, in the past, I started working on I finished working on the James Webb Space Telescope about 10 years ago. Space projects can be very long and drawn out. But with this new sort of capability, which we're getting in the UK to launch these small satellites, we might be able to turn satellites over in sort of a year or two. And so it means that sort of a career in space might be sort of just one or two projects. It might be sort of a series of sort of small projects. So I think there was a number of places to study, but there's more coming along the line, especially as we get these capabilities up and running.
Question from Emma. Given the climate emergency we're facing on Earth, shouldn't we be focusing scientific research and resources on saving our planet, rather than looking to colonize other planets or their satellites? Do humans deserve space colonization, considering the damage we've already caused to our home planet? I know it's a question that a lot of people grapple with.
Oh, yes. And it's a question that I debate myself. I love the idea of my retirement plan is to go to Mars and sort of just spend most of my days discovering things on the Martian surface. But at the same time, as I say, it's as if we've had a wild party here, made a mess and thinking, oh, let's go over there. So we do have lessons to learn here. But at the same time, I think sometimes we underestimate what space can give us. We often see the space in the headlines, and it's about, sort of Musk, talking about sending people to Mars, or sort of, people going into space. But the bulk of the money spent on space is sort of communications, it's Earth observations, it's sort of trying to help sort of mitigate some of the challenges of climate change. It's trying to understand climate change. Many of the satellites I've worked on are Earth observation. They're looking down here. There are the few headlines like the James Webb Space Telescope. And I think we need that because we need to be future facing. We need to know where we're going to next. But at the same time, the majority, I'd say 80-90% of the stuff that we do is actually looking down here on Earth and getting a better understanding of our planet. And it's a good way to do it. The Aeolus satellite, I was working with Tim Peake recently, and he was saying he did a quick calculation, and the cost of the climate penalty of launching a satellite into space is about the equivalent of 5 transatlantic flights. And yet with Aeolus up in space now, it's using solar energy, and it's giving us a global picture of wind speeds and how they connect and how they affect climate change. So once we get satellites up into space, we have that initial penalty, which we're trying to make greener. But when they get into space, they are helping us understand our planet. And sometimes even looking at other planets like sort of Venus and Mars, we know Mars used to have liquid water running over the surface. So what changed? Venus has sort of runaway climate change because its atmosphere is 96% carbon dioxide. Venus is hotter than Mercury, even though Venus is further away from the sun than Mercury. So again, I think we can't just be focused on looking and solving challenges here, but also space can help us solve those challenges, and they can also help us get a better understanding of our planet and potentially where our planet might be going in the future. So I think we need both. But I think, unfortunately, the main headlines that we hear is, James Webb, looking into the universe. We need that, but we do spend a lot of space resources looking down here on Earth.
I want to go to Clive's next because you kind of talked about it yourself. How confident are you that we will detect life elsewhere and when?
People ask me, as a space scientist, do you believe there's life out there? And I would say undoubtedly yes. I believe that there's life out there because we live in a galaxy called the Milky Way. And recently there was a satellite, a space probe called Gaia, and it was doing a survey of 1 billion stars in our galaxy. And so 5 years ago, I was saying, there's 200 billion stars in our galaxy. But when Gaia came along, it did the survey and we were out by 50%. There was actually 300 billion stars in our galaxy. Each one of those stars a sun like our sun. And now we're finding these planets going round. So that's just our galaxy. One of the things that the Hubble Space Telescope did is it took an image called the Hubble Deep Field. And the Hubble Deep Field looked at a piece of what we thought was empty space, which is about 1 millimeter square at sort of arm's length. And when it processed the data, it did a long exposure of 10 days. When it processed the data, we realized that tiny piece of space actually had hundreds of galaxies in it. So in the whole of the universe now, we think there are about 200 billion galaxies. And so just looking at sort of the laws of probability, I think there's got to be life out there because, 300 billion stars in our galaxy and maybe just even 1 or 2 planets going around each one of those stars, and then 200 billion galaxies. Why would life just occur here? But at the same time, the space is big. I talked about the 40 trillion kilometers just to the next door neighbor star, let alone the next door neighbor galaxy. So I think there's life out there, but the challenge is, how do we find that life and how does that life find us? And so because space is so vast and so big, and also there's something called the Drake equation, which talks about sort of the probability of finding life. And it talks about the rate of star formation, and the probability of finding a planet around a star. And we're getting more and more data around these. But again, there's other factors in this equation saying, how long does a civilization last? So I love the idea of aliens landing on Earth. And the door of the spaceship opening, and so they look out and there's dinosaurs. So we've got to overlap timing as well. So so I do believe that there's life out there. The probability of I think we might do some remote detection. I love the idea of using this detection of exoplanets, of analysing the atmospheres of exoplanets to actually find a potential of life out there. If there was aliens doing the same thing looking at Earth, there are some things in the Earth's atmosphere that can't be generated naturally. Things like CFCs. A really bad idea. We've got rid of them. But if there's traces of those still in the atmosphere, if there's aliens out there and they detect CFCs, they'll know something must have created it. Not very wisely. I don't think they'll think we're intelligent, but something must have created this. So perhaps we can do the same looking out there and actually detect signs of life, because you can detect signs of life that can indicate life, but to get a firm confirmation, this is life, I think that's the real challenge. But I think the technology is getting closer, and I put my money where my mouth is. I'd say next 20 or 30 years. Probably because
you heard it here first. You heard it here first. Next 20 to 30 years. Right. Question that brings us right back in. 11-year-old, just given a name, said, "Hi Maggie, I was wondering which planet in the solar system is your favorite and why?" Great question. I think my favorite is Saturn. What's yours?
Oh, yes. See, Saturn with the rings. But it's quite interesting because all the outer planets have rings. Saturn's just got the flashiest rings. Yeah. And there was a great probe called Cassini, which went into orbit around Saturn. It was analysing Saturn for ages. And
I know. Amazing images.
But my favourite planet is a planet I'd like to visit. And it is Mars.
It is Mars. Why?
because it's part of my retirement plan. If you look at the inner planets, those are the rocky planets which we can actually land on. Mercury, half of the planet is stupidly hot, the other half is stupidly cold, so that's out. Venus is a bit of a hellhole. The first probe that landed on Venus, it sent back data for about 20 minutes and then melted, because at the surface of Venus it's incredibly hot. And then we've got Earth, beautiful, wonderful, let's look after it. And then we've got Mars. Now Mars is about the same temperature as Antarctica. It's sort of it's just about in the habitable zone. And also, as I was saying earlier, Mars used to have liquid water running over the surface, but we think Mars might have lost its magnetic field, and so lost its protection from the solar wind, that particles from the sun, and so its atmosphere got eroded away, and so that's why it's sort of the desert we see today. But I'd love to investigate that, and so I'm thinking of making a one-way trip, because it's much cheaper. I go out to Mars, when I'm a bit old and doddering, and wonder about Mars, poking rocks, saying hello to Curiosity and Perseverance and the Ingenuity helicopter, and just making discoveries on a brand new planet. And yes, but still, again, learning the lessons, so that if we do go out to Mars one day, first of all, we need to confirm that there's no life on Mars, and that's still a slight possibility, or even ancient life. Let's discover if there was anything there once. But yes, let's learn the lessons. It's just so important.
Well, there is a question from Martin about what difficulties has the current conflict situation caused for the team on the space station? And it certainly feels, you showed us an image of, Soyuz and the Skylab team up, which I remember so well watching on Newsround as a child, on the same age as you. And that sense of space diplomacy was, optimistic when on Earth Cold War was raging. And right now, as we know, China, Russia, United States, there's a lot of tensions that have increased, and I wonder what impact that's having on what we have in space and thinking about future collaborations.
Yes, well, it's interesting because in some ways, Russia used to be supply the resupply vehicle to the International Space Station, but recently America's moved to sort of SpaceX and sort of a more commercial solution. And I don't know, space can be so uniting. So at the moment, I don't think it's people in the International Space Station. I think they're covered. I don't think it should have any conflict there. But it is nice to keep space pure. It'd be nice to keep Earth pure, but we just haven't succeeded at that. But I don't think it will have an impact. But it is quite interesting, because I was speaking to what's her name? Jessica. There was a woman who was on the International Space Station, and she was up there for about 6 months, and COVID came in. And so when she went up, everything was fine. But when she came back to isolation and sort of not being able to see her friends. So I think from the International Space Station, you orbit the Earth every 90 minutes. So you sort of see the Earth and all the different parts of the Earth. And I think that is sometimes a good perspective. We should put a few politicians out in space, because I think it really does change your perspective of things.
That thought you've just put into all our heads of who we might want to send out into space, possibly like Major Tom. I'm talking about the fictional Major Tom, not the real one, or Major Tim. Right. Here's a comment to finish with. This talk has been completely amazing. Science, society, humanity, utterly fantastic. Every child should see this, and every adult too. Maggie, we're not going to let you go yet. And you did a bit of time travel, because you've anticipated something that I was going to sort of present you, although you already have it. That's okay. Which is the Rosalind Franklin Medal, which, Humanists UK want to give you. And it's for your work to educate and entertain the public, making our celestial neighbourhood a little bit more accessible to all, for your contributions to engineering, helping to drive forward the massively collaborative effort to tease apart some of the universe's deepest secrets, and for the tirelessness with which you've sought to engage and inspire children, and in particular young girls, helping to bring about the next generation of inquisitive and curious minds. So thank you so much for all the work that you have done and continue to do. I haven't got your medal with you, have you? No, it's somewhere. You haven't lost it.
It was my birthday yesterday, and I was showing my husband, and I think he put it in the safe, and I don't know the combination.
Oh, okay.
It's really embarrassing.
Happy birthday! Yeah, your birthday on International Women's Day. What perfection. Maggie Aderin-Pocock. I think everyone. I know. I felt so frustrated that we couldn't laugh out loud and applaud you during your talk. So I hope there'll be a way in the future that we can all be in a room together to sort of show you our appreciation. But thank you so much for giving the Rosalind Franklin Lecture. As I say, thank you for inspiring us. And I know that people want to see that Clangers clip, but I think Humanists UK have a link to it, which maybe they can post on the chat so everyone can watch it. So thank you again so much, Maggie Aderin-Pocock. Thank you to everyone from wherever you are have been attending. Really appreciate it.